I guess we can begin. Hi everyone, my name is Alina. I'm super happy to be here, and I'm super happy to see you all here in the room. It's my second time here at JFOL. I was also here last year. I liked that a lot, and I agree with my friend Garrett, who says this is the best one-day Java conference. It's really amazing. I'm happy to be here. And in this session today, we will talk about GraalVM and how you can use GraalVM, and specifically native compilation of Java applications to the best of possible scenarios. So we will talk about building, testing, configuring, deploying your applications, using different libraries with it, etc. And I want to do this presentation in a slightly different way, in a new format, and I'm very excited about it. So I want to do basically a no slides at all presentation. I brought a few slides just to use them as a background because we have all those awesome big screens. But I want to do the session in a way that I'll tell you a story about GraalVM, and I show you the code, and I do it without the slides. It's not like there is something wrong with the slides, but I feel like I can tell an interesting story about GraalVM without the slides. And I'm very excited about this format, and I hope you will like it, but let me know afterwards if you like it as well. Let's go then. So I'm a developer advocate for GraalVM at Oracle, and more specifically, I work at Oracle Labs. And Oracle Labs is this R&D division at Oracle where we're doing a lot of new bleeding-edge projects. We are doing a lot of research, and then that research kind of becomes real-world technologies that you can use. And GraalVM is a good example of such a technology. We started this project, I believe, something like 14 years ago. And it took us almost 10 years of research to make it happen and to get it to the point where you can now use it in production. And it's a huge project, and it's so overwhelming because there are so many things that you can do with it. So when we were first releasing the project, I think it was 5 years ago that we released our first production builds. And together with that, we published a blog post saying top 10 things to do with GraalVM. So not only 10 things, but top 10 things, because there is way, way more than you can do with it. There are so many components to it. But specifically for Java, I think there are 3 main things that you need to know about GraalVM. So one thing is that it's a normal JDK. So you can use it as a JDK of your choice. You just download it, point it as your default JDK distribution, and you use it as you would use OpenJDK, Oracle JDK, whatever is the JDK of your choice. And it works just as any other JDK, so you can use all your tools, libraries, IDEs. You can use all the kinds of reflection that you like. The only thing that is different about the GraalVM as a JDK is that we are replacing the top-tier compiler. In OpenJDK, that is C2. In the GraalVM JDK, that is the Graal compiler that we wrote ourselves. It's a brand new, highly optimizing. Many teams will see performance improvements just from moving to C2 to GraalVM as a JDK. And what's interesting, our compiler itself is written in Java. So if you go to our GitHub, I mean, it's also open source. So if you go to our GitHub and you look at our source code, you will see that the compiler itself is written in Java. And you might be wondering, OK, it's written in Java and sounds like compiler is something that is operating under a lot of loads. So how does that work? You know, that Java has a bit of a warm-up curve when it comes to bigger applications. So what we did, we compiled the compiler with our native image tool to a native executable. So when you're getting GraalVM builds, you get a compiled native executable version of the compiler that we compiled ourselves with the native image that we will talk about today. So that is pretty cool, I think. And if you're a Java developer, I think it's very interesting to go and dig up what it's like to write a compiler in Java itself. Now, another part of GraalVM that maybe you have heard about is that it's also a polyglot VM. So maybe you heard of our projects such as GraalPy, GraalJS, Truffle Ruby. There are more languages that you can run on GraalVM that are not just Java JVM related. And a cool thing is that we also have a language implementation framework called Truffle. So if you always wanted to have your own language implementation, you wanted to be a language author, you can do it using GraalVM and Truffle. All you have to do is you write an interpreter for your application, for your program in Java, and then we take that interpreter, take your app, and we compile it at the runtime to a highly performing optimization of that interpreter and that application. So if you always wanted to be a language author, GraalVM gives you a way to do it. And actually, we have a bunch of community implementations of languages. So there are kind of official versions coming from our teams, that is Python, JavaScript, etc. But also there are community implementations of languages on GraalVM. One that I like is Lua. So we have a Lua implementation on GraalVM. And another one of my favorite is that we have not even one, but two brainfuck implementations on GraalVM. So if you always wanted to have a hobby project and implement a language, GraalVM gives you a way to fairly easy do so. And the last but not least is our topic today, so native compilation of applications with GraalVM and AOT. So why native? If you ever heard of GraalVM and native image, you might have heard that it compiles applications to native executable, and then they are super fast, use way less memory, etc. And it is true, and native image offers a new kind of additional deployment platform for Java applications in addition to running them on the JVM. So the way this works is the following, is that when you take our native image command and give it to your application, and that is in bytecode format, so that will be a jar or your class file, it will take your application and it will compile it ahead of time into a native executable. And this sounds quite unusual for Java, so why would I need a native executable if I can run my application on a JVM? And the reason you would want to compile to native is because we then would make your application fully working on its own as a native app, so you no longer need a JVM to run. And the idea here is to move all of that work from runtime to build time. So if you ever compiled a bigger application with GraalVM native image, you might have noticed that build time increases a bit comparing to what we are used to when we are building applications on the JVM. And the idea here is that when your application first starts on the JVM, there is a lot of work to be done. So you need to, if you're talking about the very first cold start, you need to load the JVM executable itself, you need to load all the classes, look at them, understand what is happening in the app, start interpreting, start compiling, etc. And that is where this warm-up of Java applications comes from, because there is a lot of work to be done before your application can be fully optimized and run with the best peak performance. Now, the idea of native image is to take all that work and move it from runtime to build time, because I think we can all agree that most applications are built way less often than they are run. So it kind of makes sense to do all of that work once at build time and not repeat it every time you start your application. And that's another interesting point, I feel like here, is because, again, if you think that native image takes a while to build your app, it is true. But also, it's not introducing any additional overhead. That overhead is the work that you would have to do anyway when you are starting your application, only we are moving it from runtime to build time. And another thing to know about this build process, before we get into the actual apps, is that this build step is happening under closed world assumption. So when you are building your application, you need to let us know everything there is to know about your application so that we can analyze the whole thing, compile it, optimize it, and put it into native executable. And it's very important here because you cannot then add any random unpredicted behavior at runtime. So this is happening under closed world assumption, and we need to be able to tell exactly what the application is supposed to be doing. So we need to discover all of it at build time, and you need sometimes to also give us configuration for things like reflection, serialization, etc. So all this is happening at build time, but what is interesting is that sometimes people see this closed world assumption as a limitation. So, I cannot load new classes at runtime. What if I want to load new classes at runtime? But I see it as a maybe different deployment model and maybe a different design choice, because while it is limiting in terms of random things you can do at runtime, it's also good because having this ahead of time compilation under closed world assumption, we can apply more aggressive optimizations to your application, because we know what exactly will happen at runtime, so we can be very aggressive, for example, in eliminating methods, in knowing which types will occur, etc. So this can be seen as limited, but also this gives us additional benefits, and more specifically around performance, and we will see it in a bit in a demo. OK, so we are building our application at build step. It's very important. It's happening on the closed world assumption. Seems like a lot of things to keep in mind. Why would we want to do it then? There are several benefits of running on native image versus running on the JVM. The first one you probably have heard about, that is the startup. So if you ever built an application with GraalVM native image, you saw how it starts instantly. We even see some crazy numbers shared. I believe it was a Micronaut team who had a web application start in 6 milliseconds with GraalVM native image. So they start really fast because, as I mentioned, we move all that work from runtime to build time. But here, sometimes people tell me, OK, but what if I don't care about startup that much? Maybe I have an application that is running for a while. I don't deploy it that often. I don't build it often. So why would I care about startup? It's not so relevant for me. And I can agree with that. Indeed, not all applications, not all scenarios care about startup that much. So why do native then? Another interesting benefit is memory usage and resources usage. So unlike the JVM, we are no longer compiling, analyzing, etc., profiling your application at runtime. And we don't need that whole code execution infrastructure at runtime. So you can significantly reduce that resources usage by doing all that work as you are building your app and no longer at runtime. So memory resources usage and also packaging size. So you can produce a version of your application that is very small, and then you can more easily deploy and scale it as you would want. And another interesting side of native image, which I feel like is not talked about enough, is security. And that's very interesting how the security profile of native applications is different than those on the JVM. So one thing, I said that everything that is there to discover about your app, like for example, AOT classes, that all that needs to be known at build time, and then at runtime, you no longer can load new classes. And in a way, it can be seen as limiting, but also it's an additional security benefit because there is no additional arbitrary code execution at runtime. You know exactly what will happen. And related aspect to this is that native image, it will analyze your code at build time. So it will look at your application and the JDK classes it's using and all dependencies. And it will only include those parts that you're actually using into a native executable. And then it will eliminate everything else. So if you're using, let's say, some dependency that maybe you don't trust that much, or maybe it's enormous and you're using just a slight part of it, it will eliminate everything that is not actually actively called in your application at runtime, and none of that will end up in the native executable. And this way it's smaller, but also this way it's safer in a way because code that is not actively with your explicit kind of control and awareness included in the app, that will not be included if you are not using it. And one more aspect here is that things like more dynamic Java features, so serialization, proxies, resources, etc., in native image world, they need to be explicitly enabled. So you have more control and awareness over what happens in your app in terms of reflection and serialization. So this is maybe an outcome of this closed world assumption, but also it's interesting in terms of security because you cannot attack that app from those sides. And last but not least, there are certain attack vectors that target specifically just-in-time compilation. So those are just not possible in native image because there is no just-in-time compilation anymore. It's all native code at that point. OK, so let's say maybe I convinced you and you want to try and build your application for yourself. So how would you go about it? If you want to write a new app, or maybe you have your existing app and you want to take it to the native image deployment model, there are two pieces of advice that I can give you. The best way to go probably would be to use one of the frameworks that work with GraalVM native image. Luckily, all major Java frameworks have good integrations with GraalVM native image. So if you're using Spring Boot as of 3.0, if you're using Micronaut, Halidon, Quarkus, all of that works with GraalVM native image. And in fact, they actively recommend using GraalVM as a deployment model. Now, if for some reason that is not possible, so maybe you're not using those frameworks, or maybe you just want to write your app from scratch on your own, the next best thing you can do is you can use native build tools, and that is Maven and Gradle plugins coming from our team. And those will help you build and then test your application, deploy it, and also include different libraries in it. OK, this is loading, so this is what it looks like. For example, if you're using Maven, it's just a normal Maven plugin that you're adding to your app, and this enables this native compilation step. OK, I hope my hotspot is still on, and this is, I can also show to you live. Let's clear this. OK, seems on. So what I have here is my Spring app that I just created at starterspring.io. And I added a controller here, so we have a nice endpoint. And let's look at our POM.xml and what is happening there. So this part, I would say up until about here, is something that you just get from scratch from Spring if you are adding GraalVM as a dependency. And I added some more parameters to our Maven plugin, but we will talk about that when we get to the performance section. So this is you get basically out of the box when you're generating your GraalVM Spring project. And then when you did it, you can just run your application with, build it with Maven p native compile. OK, looks good. And this is, I mean, every framework has their own way of doing those things. This is just a universal Spring way of compiling applications to native. So it will just now compile application to native. And what I'm saying, this is how Spring works with native Maven plugin. It's actually kind of cool, because when you go to start.spring.io and you want to generate a project like that yourself, if only this will load. So Java version, whatever, doesn't matter. If you add dependencies, the very first dependency that you see on the list here is GraalVM native image. So that's very cool, and we have very nice integration and collaboration with the Spring team. For the longest time, this support was incubated in the Spring native project, but now this is included in the mainline Spring. And it's also kind of interesting what the Spring team did to integrate with GraalVM native image. So now they have this new Spring AOT kind of engine and AOT phase in the build process. And what this does is that it will help you transform your application to make it GraalVM friendly. And Spring will generate for you source code, bytecode, and config files to make your application friendly for GraalVM. But luckily, this just works out of the box, and this is on the Spring's side of things. And this is not something you have to worry about. I just find it interesting how they make this work. It's really cool. So let's look at our app. Our build succeeded. And now when we try running it, let me just move this up probably. OK, it's target demo. Target demo. So we see that it started in something like 43 milliseconds. I would say it's not bad. And when we go to the endpoint, we see our message there. So that's a bare minimum kind of starter way of going with Spring and GraalVM. So what else do you need to know if you will build such an app yourself? Let's look at our Maven plugin. And one thing that I find helpful is this configuration section here. And this is in our Maven plugin. So if you want to customize the build, and there are many ways to customize the build. So maybe you want to use some additional libraries. Maybe you want to give more strides to the build process. Maybe you want to pass some options to native image itself. So this configuration section is the way you would do it. And we had talked about dependencies. So let's say I want to add a dependency here. So how would I do it? And in general, many people ask me, I want to build my app, but I'm using dependencies X, Y, Z. So how would I know if that works with GraalVM or not? So the easiest way to evaluate it is that we have a community kind of maintained and contributed list of libraries and frameworks that work with GraalVM. So if you go to our page, which is called Frameworks Ready for Native Image, you will find it on our website. And there are major frameworks and a very long list of libraries and tools that work with native image. It's probably bigger in reality, but those are this is the data that was contributed by community that people are actively testing and integrating with native image. So let's say I want to know if maybe H2 would work with GraalVM native image, and it's here on the list. And let's say I want to use maybe, I don't know, Postgres. So I can also find it here. So this is the way you would validate that those things are working. Now, the ideal way to work with GraalVM native image and external dependencies is when a dependency is including configuration for GraalVM in the library itself. So here I used to show a demo how to make H2 work. But luckily, I don't even have to show it anymore, because when we go to the H2 source code here on GitHub, and we look for reflect config, here it is. So we will see that H2 itself ships configuration needed for GraalVM native image. And the reason why we need this configuration is because, as I mentioned, we are compiling your application ahead of time. So we need to know all those things at build time. And reflection is way more dynamic, right? So there is a way to work with reflection in GraalVM and in native image specifically, but you need to let us know what exactly you want to do in terms of reflection, serialization, etc. And there are many ways to do it, but the preferred way is that when a library that is doing reflection or all those things provides this config within the library itself, and luckily H2 does so. I mean, here they're saying that they added experimental configuration for GraalVM native image, but I tried it, and I had an app where this didn't work, and now it works. So this is the best way to include libraries in GraalVM native image. But what if your library hasn't added support for GraalVM yet? So can you still use that library? You can, and then if there is no config in the library itself, the best thing you can do is that you can get this config from this place. And this is a centralized repo that we created on GitHub for libraries, frameworks, etc., that haven't maybe yet added official support for GraalVM native image, but this is a centralized place where library framework authors, but also users, can contribute and then reuse that configuration for their own builds. Because maybe you want to use, I don't know, library X, which doesn't have config for GraalVM yet, but somebody else maybe already figured out that config. So what is good to do is to contribute it to the centralized place. And luckily, we have a lot of contributions here, so all those libraries will just work through this repo. And then all you have to do, if that config is in this repo, is just go to your build file. And here I'm saying metadata repository access enabled. So what this will do, if I had one of those libraries here in my application, this will go, as I'm building my application, this will go to this centralized repo, will look for config, and it will pull the config automatically from there. I don't even need to specify which kind of library I want to use. I'm just saying, hey, I know this repo exists. Can you please go there and get the config from there? So this is the second best thing to do about configuration if you want to build your application with GraalVM native image. Now, if it doesn't exist even there, and if library haven't added support yet as well, there is yet another way, but I hope you will never have to do it. So native image itself includes a tracing agent, and what you can do with this agent is you can run the application on the JVM, apply workloads to it to replicate as much real kind of world behavior as possible, and then this agent will observe your application behavior and will output those config files for you. And then native image can pick them up at build time and build an application that is aware of that usage of reflections, serialization, proxies, etc. So this is a good, and I would say semi-automatic way to provide configuration for GraalVM, but still it's an extra step, so hopefully this is not something you will ever have to use yourself. That's just the last resort if your library config, etc. doesn't yet support GraalVM native image. Okay, so this is what you would do about building, and the last advice that I want to share here for building your application is this -ob flag. So you can just pass this directly as you're building your app, but also I have my little dev profile here. And this flag will enable a quick build mode in GraalVM. So what this will do, this will speed up the build process for development purposes. So as you're still building your application and you need to validate that everything is still working, this will produce the build faster, but at the cost of runtime performance. So this will skip some of the optimization phases, just so you have the build faster, but it will not have the same runtime performance. So this is a development tool. If you want just to quickly build your app and see that it's working and nothing breaks, this is something you would use. But please remove this flag as you're moving your application to production. So maybe it builds a bit longer, but it has a better runtime performance. OK, this is about building. And let's say we want to build such applications ourselves. So how would we test such applications? So let's talk about testing. And in general, for both testing and development, our advice is when people ask us, so how often do I need to build my app in native? How often do I need to test in native versus how I normally develop things on the JVM? And our advice here is that you normally would build your app still on the JVM, even if your final destination is GraalVM native image, and then you would compile to native maybe in your CI/CD pipeline somewhere, or once in a while, or if you have touched things that are sensitive for native and you expect that you broke the build yourself. But this is not something that you need to constantly recompile as you're still working on your application, because that's just not efficient. This is not something we would recommend. So once in a while in CI/CD pipeline, or if you were touching reflection, serialization, etc., but you don't need to constantly recompile to native. You can just rely, especially if you're using frameworks and libraries that are working with GraalVM, that everything will just work. We don't think that you need to constantly recompile to native, especially if you're introducing changes mostly around your build logic and not something low level. So let's talk about testing and how you would test such a native app. For that, let me go here. And I have another app. Where is it? This one. So here's my app. And I have a calculator class here. And also, I have some tests in place to make sure that my calculator class is doing some reasonable job. And when we look at our POM XML, once again, we have our Maven plugin that will help us test this application in native. So let's see how we would test it. So what's interesting here, if you ever compile the application to native, you already recognize this output. And what is happening here as a part of this test step is that we are compiling our tests themselves to native. So as an outcome of this, we will have our tests compiled to a native app so that we can validate that our app works just as expected in the native mode. But I think it's kind of cool that we do not just somehow verify the assumptions, but we actually build the tests to native themselves. OK, so this is done. And also, I want this noted that this built in 24 seconds. So the next time somebody complains to you, the GraalVM takes forever to compile something, you can show them maybe this screenshot. And as a part of this stage, we also got our report printed out here for us. And we see that all of our tests that we had in our test class have passed successfully. But you don't need to take my word for it. So we see what was the produced artifact. And another thing we can do here is that we can just go and execute those tests directly. So native tests. And we see the same output. So those are our tests that are being compiled here to native. OK, but this seems fairly straightforward. So what if I want to test something a bit more advanced? Maybe I want to do my integration testing, and I want to validate that my native application works just as expected in the native mode as well. So what I can do for that? For that, let's look at yet another app. OK, we are looking at this one. This is a little book app created by my colleague Cedric Champeau. So what we have here is basically a list of books. Let me move this down. Books, authors, etc. And we want to use MySQL here to be able to host our list of books and retrieve them from the database. And we also want to be able to test that this application is working. And among other things, it can read and then put a book in a database and then read from the database. So how would we do it? So this one works just as well in the native mode. And the way I would test it normally is like this. So Gradle native test. So this would be the way I would normally do it. But because I'm on the bleeding edge and I'm on GraalVM for JDK 21, and not all of the ecosystem had a chance to pick up 21 yet, and I didn't want to bother configuring those things. So what I do instead is I have this little script over here. So basically what I'm doing here, I'm switching back to GraalVM for JDK 17. And I'm just setting Podman as my Docker environment. And then I'm executing the same build command. So maybe let's move this up. And let's do this. OK, so this is starting now. And to validate that our app works as expected, we need our MySQL test container. And this is starting here. So what is working here is that we have this Micronaut test resources module in Micronaut, but there are similar things in, for example, Quarkus. In Quarkus, it's called Quarkus Dev Services. And Spring Boot, I believe, added direct test container support as well. So what is happening here, we are relying on test containers to provide that MySQL container for us so that we can validate that our test and our app works just as expected in the native mode as well. So when it comes to testing, the rule of thumb there is look at your framework and what kind of testing support it provides within the framework itself. And that will be a good way to go. Or if not, again, native build tools will help you. But also, if you're using, again, one of the frameworks that I mentioned, so I believe that will be Spring Boot, Micronaut, and Halidon, they have under the hood native build tools included. So if you need to customize something about your build and you're using one of those frameworks, there is this Maven or Gradle GraalVM plugin already included. So this is how you would test such an app. And one more helpful thing in terms of testing and native build tools is that there is also a JUnit support. So you can specify if you want to specifically include or exclude some classes and methods for testing in the native image mode as well. This is coming from JUnit. OK, cool. So now how would we deploy such an application? And one thing to know about native image is that out of the box, we are producing native executables that are platform and architecture specific. So if I'm building my app on my Mac ARM machine, it will produce a native executable that is suited for this specific platform. And that's because there are some things that are platform specific, for example, around the GTK classes, etc. So out of the box, you cannot produce cross-platform builds with GraalVM native image, unfortunately, but there are things to do about it. One such thing is you can use your CI/CD pipeline. And as an example here, we can look at, no, I don't have it open. So there is this famous game of life program that we took and we re-implemented with GraalVM native image. Here it is, and we have it on GitHub, and we have set up GitHub action to test that this works, and in particular works with our latest GraalVM builds. So here, for example, we moved to GraalVM JDK 21, so to the latest version. So what you can do here is you can set up something like GitHub actions for your CI/CD, and then you can produce native executables for your target platforms, and that is probably one good way to do it. There is also a setup GraalVM GitHub action, so the official GitHub action coming from our team. So if you want to use GraalVM with GitHub actions, doing something like this is a good way to go, and then you can produce native executables for all your target platforms. OK. OK, and let's talk about my favorite topic, and that is performance. So how do you think, what is the peak performance like of native executables versus the JVM? So are native apps faster? Are they slower? What do you think? Faster? You are very optimistic. Because usually when I ask Java people about this, in Java ecosystem, we are so used to the dynamic code execution that we assume that just-in-time compilation is unbeatable because you're running your application dynamically at runtime, you have your profile information, you have your choice of GCs, etc. It's very hard to beat JVM and its own game. And JVM is indeed amazing and a great piece of software engineering, and it's very hard to beat in terms of peak performance. But we believe that we can do it. We are very ambitious, and we believe that we can do it even with ahead of time compilation. So let's see how we would do it. And for that, I want to show you a very interesting benchmark. I hope we can get this to work. OK, so we have our Spring application over here. Let me maybe just go there and get it to run. I'm almost forgetting that it's not called demo, but it's called Spring Pet Cleaning. OK, so this has started, and I already have it compiled as a native app. Let's first look at what the app does. I think you all have seen it, but let's take another look at it. So this is already compiled as a native image, and I have a bunch of versions to it. I just started one of them, doesn't matter which one. And it's running, and it was up in 235 milliseconds. So if we go and check it out, localhost something. So it's a normal app where you can add owners, add pets, look at veterinarians, create visits, etc. And this is kind of standard benchmarking app, but also one that is intended to more or less replicate real-world behavior, where you have a web app and you need to store some data, read some data, and we are trying to emulate it here on this app. So let's talk about our benchmark, because it's very interesting. So we will measure performance of this app in a couple of modes, and we will use a proper benchmarking setup for that, or at least as appropriate as it gets at a conference. So first, let's look at the request that we will send, and we will talk about the actual workload in a bit. Let me just kill this. OK, let's first talk about the request that we will send to our application. So this is a list of requests. And what we will do here is we will create a new owner. Then we will create a path for that owner. Then we will create a visit. Then we will read the data. So we will try to emulate more or less normal behavior of a web app. It's not like we will just get the app to run and then we will hit like one endpoint with a million requests. So we want to be smart, but also fair and replicate normal behavior. So this is the kind of request that we will create. Now let's look at the benchmark setup itself. So first thing I want to do is I want to run this application on the JVM, and I will run it on the JVM with C2. So C2 is your normal OpenJDK compiler. Here I'm still running on the JVM, but I'm turning the GraalVM compiler off. And this means that effectively I'm left with the OpenJDK kind of setup, because without the Graal compiler, it's basically your OpenJDK. So I will run it on the JVM first, and here's where it gets interesting. So we will start our app, and then we will wait for 10 seconds. So we are giving the application a chance to actually start. This is not warm up yet, so we are starting the app, and we are giving it 10 seconds to actually start. We think it starts in around maybe 5 seconds, but we are giving it 10 seconds just to be fair. Then we have a warm-up run where for 10 seconds, we are sending the load to the app. We are given a chance to warm up and reach that peak kind of cruising speed. And only then we are doing the actual benchmarking for 20 seconds. So we are giving the app a chance to start, to warm up, and only then we will benchmark. And we feel like this is, I would say this is close to normal kind of professional benchmarking, or as close as you can get in a conference talk. So we are trying to be fair to the JVM, give it a chance to start, to warm up, etc. So let's see how this works. Let me move all of this up, and let me clear this. So bench jet C2. OK, now it starts. And on my machine, this is a good cloud machine. So again, it's not like I'm abusing the JVM and putting it in a very small instance so it doesn't have a chance to shine. It's a very good cloud machine, and we are giving it a chance to start up. And now we are actually warming it up and sending the request so the app has a chance to warm up. OK, warming up. And now we will actually do the actual benchmark run. And for that, we are using the tool called work. And we will send the request that we saw in the Lua script. And you will send as many requests as you can process in that given time frame of 20 seconds. OK, so this is done. And the peak throughput that we have here is 1.6K requests per second. Let me maybe move this higher up. OK, so the throughput is 1.6K requests per second. And still, I feel like this has been warmed up already, because I did a trial run before the session to make sure my demos work. So it kind of warmed up a bit, I would say, before I did the session. Nevertheless, this is the peak throughput that we get on the JVM. So let's see what the native application would be like. Let me just get another tab. And let me do this bench. Where are we? Yeah. Bench native, and let's just run a plain native app. So here we got 1.6K requests per second. Now we are running the native one. What's interesting, we are giving it the same 10 seconds to start, but we don't have to, because it's ready to go from the first seconds. But just so we have the exact same setup as we had with the JVM, we are also giving it 10 seconds. Now it's warming up, and now it's actually benchmarking. So who thinks this will be faster than the JVM version? It's a demo, so probably, I tweaked it in a way so it is faster, right? But, let's see. OK, it's done. OK, I think I've seen better throughput results, but let's take this one. So here we got somehow 1.1K requests per second, which is a bit behind the JVM. Again, the JVM is an amazing piece of engineering, very hard to beat it. I think I've seen better runs. I think I've seen like around 1.3 rather than 1.1, but let's take this result as an optional performance result for native image. And now let's see if we can improve this run. And for that, let me get yet another tab so we can compare all of them. And let's do bench native optimized. And let's look in the meantime at the profile that we have for this app. Are we looking at the right one? Nope. AOT performance, POM maximal. Still not the right one. AOT performance, Primpad clinic. Over here. Got it. OK, so what is happening in this optimized profile is that we have a bunch of additional optimizations enabled there. If I only can get them. Yeah, this one. So I have these 3 additional options in this run. One is profile guided optimizations, the first option. And this is the optimization that allows you to build an instrumented version of your app. Then you run it with relevant workloads, and you collect those profiles. So the same kind of profiles that JVM collects at runtime, you can collect those, and you can give those to us at build time. And this way, you can get the best of both worlds. So you're still building and optimizing your application ahead of time, but you have kind of an insight into that application's runtime behavior, and you can use that insight to optimize at build time for specifically your application's behavior. So you can apply very aggressive AOT optimizations, but build the app for its runtime behavior. That's one very powerful optimization. And it does require an additional run. I did not do it now, but the way you would do this is you would build an instrumented binary, you will run it with workloads, you get the profiles, you rebuild again, and you get way better performance. Now, it could be the case that it's not possible for you to do that many steps. So if you cannot do it, there is the next best thing, and it's called ML PGO. So in native image, we have included an ML model that if you don't have any profile information available at all, we will try to predict profiles and then optimize your application based on those profiles. So this works out of the box, and it's on by default in Oracle GraalVM. So if you don't have any profiles at all, this ML PGO will give you something like 10% extra performance, even without this extra instrumented build step. So PGO is one helpful thing. The next helpful thing is this MARC native flag, which means that I want to use the best hardware features of this specific machine. So if I'm deploying maybe on other machines, I will not use it because it will break compatibility a bit. But if I know that I'm building on the machine where I will use the app, I want to leverage as many specific hardware features as possible. That's one thing. And then in terms of GC options, I'm using G1 GC here. There can be different GC strategies in native image, but usually if you target peak throughput, G1 GC is the best way to go. OK, let's see if we manage to beat the JVM this time. OK, so what we have here is 1.6K requests on the JVM. We have 1.1 native out of the box, which I think we still can do better. And then we have 1.8 with all those additional optimizations available, so slightly above the JVM. And if it doesn't look that much of an improvement for you, still I want to remind you that JVM is amazing. It's very hard to beat it at its own game, and this is the performance improvement that you can get in addition to startup, memory usage, security, etc. So it is possible to achieve high peak throughput with native image, but you do need to apply those few extra steps to make it happen. OK, and as we were doing those benchmarks, we also used a very interesting tool called PS Records to look at our application's resources usage. I just want to mention this briefly. So here is one chart. Here is native. Come on, come here. And here is our native optimized. OK, so let's look at what's happening here. Let's maybe remove this. So this is the runtime behavior and resources usage of our application in all the 3 runs, so C2, native, and native optimized. And you can see interesting things here. One is, you remember we had a startup run where we just got our application up and gave it a chance to properly start up. That's the first 10 seconds. And you can see how in native image, there is nothing going on in 10 seconds. So the application just sits there and waits until we send some load, because we were giving the JVM a chance to properly start up. Then when we actually send our load, and the way to read this is the red vertical lines, that is CPU usage, and the horizontal blue line, that is memory usage. And you can see how much less memory native image is using, same as CPU, because there is no longer all this compilation and code profiling, etc. work happening at runtime. OK, I'm so sorry. I think I'm looking to the same charts. Let me get the other one, native. Because I was looking at GC behavior, and then when I noticed that something is wrong. Yep. OK, so the medium one, that is plain native image. And this, by default, it uses serial GC. So what we see here is that memory usage is lower, and it's very constant, but you get serial GC instead of G1 GC. So if you want the best peak throughput, the one that we got here, most likely you would need to use G1 GC. Be ready to maybe add a bit more memory usage, but in general, I think it's a common kind of agreement that you can always trade off memory for throughput. So if you want maybe slightly better throughput, consider using G1 GC. But serial GC is also a valid option if maybe you want to minimize memory usage and maybe you don't need such good peak throughput. And we are almost out of time, I believe, but I do want to show you one last scary chart, if I can get it here. OK, the last scary chart, and then we are done. So this is my all-time favorite, I feel like, performance metric. And what we are looking here is operations per gigabyte per second per XMX. And what we are comparing is C2, so basically OpenJDK, and Oracle GraalVM native image. And the C2, so OpenJDK1 is the blue line, and native image is the orange line. So what we can see here is, I think, two observations. One is how much throughput you can get per resources per time, and how that correlates to your XMX settings. And what you can see here that no matter what are your XMX settings, consistently you would get more performance with native image per memory per time than with C2. Because as we've seen, you can get good performance, but you're using way less memory. So for the same resources, you can get more throughput. And another interesting observation here, and this is again a Spring Batch cleaning application. So somewhere around here, and I would guess that's probably 512 megabyte heap size, you can get even twice as much throughput per memory per time than you would get with OpenJDK. And then it's still better, but I feel like if you want to really like squeeze the max out of your resources, the sweet spot of around 512 megabytes and up until 1 gig, I would say, is the actual sweet spot for to get the best peak throughput for your available resources. OK, so that was the performance section, and that's the end of scary charts. And I want to mention a few quick updates about what I'll be working on next and what are the big updates coming to GraalVM. So one thing is that now we release on the same day as Java releases. So when Java 21 was released, we also released GraalVM for JDK 21. And on the same day, when you want to get a new Java version, you might as well get a new GraalVM version and have all the latest versions of Java, all the latest features, and all the latest features of GraalVM. So that includes also virtual threads from Project Loom. They are now GA in Java itself, and they are now also GA in GraalVM. And we have a very good virtual threads implementation on native image specifically. So if you want to have really fast virtual threads, I do recommend that you check out GraalVM and native image. That's one update. Another thing is that we are working on something very ambitious called GraalOS. I really like the name. So we want to have our own kind of operating system. And this is where you can deploy your applications as applications and not containers. And we will take care of running those, scaling those, etc. And we will make sure that you can use all the hardware features and you can do isolations without containers. So sounds very ambitious, and the name itself is very ambitious, but I think it's very interesting, and follow us, and we will share more news about it. And the last update that I wanted to mention with you is we are working on something called layered native images. So now, as I said, you can build a native image, and it will include all of your dependencies, JDK classes, etc., and it's fully kind of self-contained. And we want to offer you a new deployment model in addition to that, where you would have your base image. So let's say you are building a Micronaut application, and you would have a base image, kind of like, you know, like in Docker, you can have layered images. So we want to give you the same way of having, let's say, Micronaut core, Micronaut web, Micronaut data as a base image. And then you only need to recompile your actual application code, but you don't need to recompile the base. And we believe this can be helpful to improve both build times, because you will only recompile your application code. But also, if you have multiple instances of that app deployed, they can share that base. and they can use less resources because they can share the base image. OK, and I do have one proper slide in case you want to have a summary of what I said here. So if you want to take a photo and note or something, I did bring like one slide. And I will give you a chance to take a photo. And I know I'm running over time, so if you have any questions, you can just, oh, sorry, let me go back. I see people still taking photos. So yes, that is the summary of this talk today. And if you have any questions, you can just ping me on Twitter. And I also have this repo on GitHub, which with a list of what I think are good resources about GraalVM. So you can also take a look at that one. And with that, OK, people are still taking photos. OK. With that, that is all that I had today. I really hope that you like this presentation format where it's story and code rather than slides. I personally like that a lot. And please rate this session and give me your feedback. And thank you all for coming. Enjoy the conference.